product that has emerged as part of your containerization success. So the Docker has got three different sections. One is called your Docker engine, where your actual Docker daemon is running. So that is called your Docker server, which will respond to all the API requests coming out of your Docker client. So Docker client can be installed on any of your machines. It can be installed on Linux or Windows or Mac OS. Even for connecting your Azure container instance, you can also manage it using your Azure command line, or you can manage it using your Docker client. You can connect and manage Azure container instance. And you also have Azure Container Repository or Registry, which is equivalent to your registry, which is equivalent to your Docker Hub, where you can go and create your containerized packages, and you can store those container images in the container registry. Okay, so Azure Container Service, as I told you, it is a technology that evolved from Docker. So containers has become the easier way, or instead of easier way, I would say it has become the preferred way of running the apps on cloud. It is very easy to package, deploy, manage, migrate everything. So Azure Container Instance, it allows you to deploy and run containers on Azure without managing the server. See, comparing to your Docker or containerization stuff, so in Docker, what we generally do is we have a physical server, and we install the Docker. See, we have an operating system here, and we also have a Docker engine installed on your physical operating system, and we have the containers running on top of it, right? This is how it works. Maybe let me do one thing instead of, okay, let me try to open up the PowerPoint here and then try to show you the difference. Yeah, micro VMs will be a little tough. Okay, so here earlier what we generally do is with hardware virtualization with your initial one, right? With virtualization, we had a physical hardware, we had an operating system, and we had an application running on it. So we have used to create a separate VM for each of your application. So each VM will have its own independent OS and independent prerequisite that is needed for your application to run. But here on your base OS kernel, we will be directly running the containers here. And I think this comparison, where is that? I think this is okay. So earlier we used to have a physical hardware where we used to have a physical operating system directly installed on a host hardware, and we used to install all the prerequisite libraries, and we used to run application on the direct physical hardware. So with virtualization, with containerization, we have the physical hardware, we add the container engine on your host operating system. This container engine is nothing but your Docker, LXC, or Vagrant, or any tool that you run, and we can directly run your application independently as a container of on top of your host operating system. So each container will be packaged as a separate deployment item, where the developer will be creating the packages that is consuming that consist of your libraries, dependencies, scripts that is needed for your application, and it can run independently. So here in your hardware virtualization, in your VMware or whatever technology that you are using, Firecracker or Hyper-V or any technology, we used to have a separate set of guest operating system. Either it is a full virtual machine or a micro VM. Both the technologies, it uses a full guest operating system for your each and every virtual machine. Either it is a micro VM or a full virtual machine. So you need to have a complete set of service. So between micro VM and the full virtualization, so VMware uses the separate guest operating system. So here the only difference is we are using a Linux kernel directly on a hardware where we are running a kernel virtual machine. So this is where we call it as micro VM. This is a technology that is hypervisor technology on your Linux flavor. So irrespective of micro VM or VM, we need to have a separate guest operating system for each of your virtual machine. That will consume a lot of hardware resources in terms of disk, CPU, and memory. Whereas in your containerized workload, you don't need a separate operating system. That itself saves a lot of 40 to 50% of your unnecessary wastage of storage capacity here. So in cloud, what we need to do is we just need to manage only the containerized workload. So the underlying hardware, the underlying host operating system, the container engine, all these are provided as a managed service. So with Azure Container Instances, it's a fully managed containerized environment. Microsoft manages the physical infra, the host hardware, the OS, the Docker engine, or I would say the container engine instead of Docker engine. The container engine, everything is managed by Microsoft. Customer is responsible for software development and managing container instance only. So if you ask me whether you need to have the understanding of hardware, no, you don't need to have the physical hardware understanding. You don't have to have idea about operating system. You don't need to know the Docker concept. You just need to. You don't have to really learn any new tools. You can directly run your containers without managing the servers on Azure platform. So it is serverless and new tools like Docker, etc. So you don't need to manage the OS, manage the server, uh, like OS related or the container related. And whatever an amount of time that the container is running, you will have to pay only for that. So it's a per second billing for the time the container is running. So it is the very fastest way of deploying your application as a microservice. It's a very interesting solution where you can deploy, operate, and manage containers in an isolated manner. So mostly, earlier, if you want to create a batch job or if you want to create something for automating your task, so you need to go and do it on your base operating system. See here, what you can do is any batch job that you want to do or any build activity that you want to do or task automation that you want to do, even if a small application, you can go and create it as a container. So container can be for your business application, for your business applications, or it can be a batch job, or even it can be for any task automation scripts can be run on your container. It can be separately run, and there are a lot of use cases. So in some organization, if you want to manage the container platform, if you want to manage which container should run on which Docker engine or the hardware, or if you want to do a service discovery or automatic scaling or application upgrade has to be managed by yourself, then you need to go for AKS, which is a Kubernetes concept, okay, where you have full control on the container platform. If you want to have control on the container platform, then all orchestration, service discovery, all those things can be managed by the customer here. But we will see about AKS later. But with ACI, you can independently manage each of your containers. But if you want to manage all your containers and the placement and all those things, then you can go for your advanced concept called Azure Kubernetes Service, which is which gives you much control for the customer. So we'll talk about Kubernetes and AKS later. So where you get complete control of your environment on a very high level. See, Kubernetes, I'll give you quick example. See, for VMware, we have ESXi hosts, or we have vSphere hosts, and all your VMs are running on top of this. And if you want to manage all these virtual machines, the vSphere hosts in a centralized console, what we do, we have this vCenter, which is the centralized platform to manage all the ESXi host or vSphere host and the virtual machine images, templates, and everything. Similarly, in container world, if you want to manage the containers, the Docker hosts, and all those things, so the centralized platform to all do all these things is Kubernetes. Okay, so Kubernetes is the centralized platform to manage your containers, host, images, templates, repositories, registries in a centralized way. So if you want to have control on managing all these things in a centralized location, then you can go for AKS, right? Azure version of Kubernetes service. So Azure Kubernetes service will give you complete access on the host where your containers are running, and you can also manage the images, templates, container registry, the containers, and so on. So it is a centralized platform through which you will get option to manage a lot of different things. But for now, you are managing each of your microservice as a separate container, and you get control to do the deployment, to modify things, or to restart the specific container. All those things are available. So ACI containers are very small in size, and restarts in a few seconds. So if you want to take downtime of your application, it is very, I mean, even restart or starts in a few seconds. It's pretty small. Okay, so few seconds. So you don't have to provision the VM, or you don't have to start the VM. So in container, there is no need for starting the entire VM, right? So here in containerized in the older days, we have to boot the entire hardware. The physical firmware will have to be checked. The BIOS has to be tested, all those things. But with virtualization, so the boot time reduced. Only the VM has to boot up, and along with your operating system. But here, even that is not needed. So there is no waiting time for your operating system to come up. So container can quickly get restarted or started in the cloud. So I'll show you how to deploy, create a Azure container instance. You have a lot of flexibility. You can go and choose the operating system of your choice, the CPU memory that you need for running this container. Even you can have a persistent storage also, like your Azure file share can be used, or you can also mount Azure storage as a backend, so that all your contents can be persistent. And you can also go and choose custom size for your CPU memory and CPU cores. The specifications can be changed based on your container requirement. And for accessing the container access, Azure provides an unique FQDN, fully qualified domain name, or you can also access it using the IP address. And whatever you are accessing the containers on your Azure ACI platform, it is very much secure. The reason is ACI supports only transport layer version 1.1, sorry, 1.2. So 1.0 and 1.1 were deprecated, so it's no more supported. And even if you want to bring your applications containers to cloud, Azure cloud, it only supports transport layer security version 1.2. So so that the connections and everything is secure. And as I told you, so you, for accessing your container, you have a unique uh, thing where you get the container name followed by the Azure region, followed by your Azure container.io. So this is the domain name you get, and the container has to be unique in each region because it has got a regional separator. So you can access your containers using the DNS name, or this particular DNS FQDN, and your applications can be configured using this. So irrespective of the backend changes, your application will still be accessible. So it supports both Windows and Linux containers. So your underlying operating system can be Alpha in Linux or Windows. So based on your requirement, so it is much simplified. It is very quick. You have a quick way to deploy it. Even if you want to create a container and run it on a private Azure VNet, you can also do that. And if you want to expose it to public internet, also you can do it. Or if you want to use it as a kind of use it for some batch jobs or some small internal activities, you can also just use it as a kind of function, which is without exposing it to private or public network. So there are three options. I will show you how exactly it looks like. Let me go to the console. So before going to the practical console, as I told you, containerization has reduced the infrastructure, physical infrastructure plus the operating system that is needed. So it has improved the complete utilization of your resources. For containers, you don't need separate operating system. So obviously, automatically your amount of CPU, memory, and the storage requirement has significantly come down, and your physical infrastructure has come down. Easily, you can create, clone, and run multiple containers as a kind of cluster. So it is very predictable in nature. So your deployments have got very quicker. Whatever changes you want to make to your application, you can do it on a regular basis. So the same day you can come up with new enhanced version, unlike your older way of managing things. So your monolithic application has become into a microservice. So the deployment has got much faster. So this is the evolution that we have seen over the period, last 25 to 30 years. So the development has changed from waterfall model. So if there is a new requirement coming from business, so what the development team will do is they will take 2 weeks or 4 weeks to come up with the new version of the application, and they will deploy it, test it, and then we used to have a waterfall mechanism or waterfall framework or model for the development earlier. That has changed to agile, where the team used to meet up on a regular basis and discuss and then come up with quick updates. Currently there is no separate team like development team and operations team. They have merged together as a DevOps team, and whatever new versions that are coming up, it will be brought very quickly with the current way of working in the DevOps model. So earlier we used to have only one application for the entire thing. Your database, web layer, application layer, middleware, everything will be put together into one single server or one single application. At least that changed into three-tier or n-tier application. We used to have web application and database split into layers, maybe 10, 15 years back or 20 years back. But before that, 40 years back, we used to have one application for the entire business requirement. Now, as I told you, every single service or process has been split into small containers. What we call it as a microservice. We call the container as a microservice. So that is the parallel evolution we are seeing. So we used to have physical servers for running your monolithic application. We started creating virtual machine for running your web server, app server, and database server. Now we have this containers to run your uh, microservice as a package. So similarly, on the application infrastructure side, we used to have our own data center. And when virtualization was very popular, we used to migrate to IBM data center or HP data center. We used to go to virtual private cloud, VPC, or hosted private cloud concept. Then now we are almost most of the workload are migrating towards Microsoft Azure or AWS or Google or Oracle. So we are adopting public cloud. So all these are parallel evolutions in software development, application architecture, deployment mechanism, application infrastructure. So there is parallel evolution that has brought us to the day where we are today. Okay, so that is the thing. Yeah, let's go and look at Okay, so little more background on how this word container came, right? See, earlier, when during the 1960s or before 1960s, before the container came into the shipping industry, there were a lot of challenges. So the people want to ship a lot of different goods like vehicles or the food products or the products which are I mean, a lot of different things has to be sent via the ship or sent via the different shipping mechanism that we have. See, if you want to send it via train, or if you want to send it via ship, or if you want to send it via some goods thing. So what we generally want to do is like we just dump it everything together. We did not have a proper mechanism to group the products for a particular country, or group the food products in a separate container for that the IT equipments or electronic equipments in a separate container. That option was not available in the pre 1960 era. So what the shipping industry came up with an idea of having a separate container. So in the same ship, if you have container, we can dock them one on top of each other. So they brought up this docking concept, and within the container they used to segregate the food products in a separate container, and whatever the items that need freezing, they will have a container with freezing capabilities. The electronic equipments will be sent in a separate container. The vehicles or different products will be put into separate containers, and they will be sent to different destinations and all those things. So shipping industry came up with this concept of docking multiple containers on a ship, and they had this container concept. The same way we had a challenge in the IT industry. There were different prerequisites, different application. We need to run it on physical server, virtual machines, and all those things. So this Docker concept or container concept, it has simplified the way that we run the customer business application. So that's the I mean, that's the reason behind the name or the evolution. So the people whoever started fixing that business challenge, they use the same analogy from the shipping industry, where they tried coming up with a concept called Docker and container, which has simplified the way that we package and develop applications for our customer. So the name came from the shipping industry. So I have explained it in a detailed way in the other video. We can just go through that. But for now, I just want to give you a heads up how the name Docker and the container came into existence. It is from the shipping industry. So let's go and create an ACI container here. Okay, so go to ACI or Azure Container Instance. So you can use this Azure Container Instance to create and manage Docker containers, okay, in Azure without having to set up virtual machine or additional infrastructure. So you don't have to create a VM, or you don't have to spin up anything. You don't have to install Docker engine. You can directly go and deploy the container in the ACI environment. Okay, that's the very important thing. So it is serverless, and even you don't have to manage the operating system also on your virtual machine. Okay, let's go and create it. Okay, let's select one of the resource group. So here you can give a container name. I will just say stan test container 1. And here you can also go for different data center if you want to. So you can select the region where you want to run this container. So here you have the standard and confidential. So if you have some workload which needs um, which is business critical, and you need more security at the physical hardware level and the VM level, you can go for confidential SKU, stock keeping unit, which is for your confidential containers. So for general purpose containers, you can go for this one. So 1 second, let me just increase the time here. Okay. So standard and confidential options are there. So this is mainly for your in-memory encryption, or if you want to have the hardware level isolation from each container, you can go for this, but this one standard is for most of the categories that we have. And the image source, you can either have it from your Microsoft Azure Quick Start Images, which is native to Azure, or you can also have your own container registry created, which is a private registry for the customer. So you can store your container images, can be coming from the marketplace, which is already available. You can also have your own private registry, which is Azure Container Registry. You can create it. You can also go for other third-party registries like Docker Hub, or third-party registries can be done. So you have the marketplace, which is your quick start images. So if you want to start creating something, you can use this quick start images. You can spin up one of the image, and you can modify and update the application code for your customer requirement, and you can do it. So here also you can run it with better discount using spot instance. So if you are having something like batch jobs, or something which runs very rarely, so as I told you, you can use it for various. If you are running it for business application, don't go for spot instances. But if you are doing an automation, or if you are doing a migration activity, or a daily copy activity, or a batch job, a scheduled task, you can go for spot instances. Your containers can be quickly recreated if in case if it is going down. So you have the option to run it as a spot instance. So here you have a lot of images. So you can just try to run one of the sample images. You can go and select something from the drop down. See, if you look at here, Microsoft provides you a container registry, which is where they are storing a lot of different container images. So here, marketplace or quick start. So mcr.microsoft.com is similar to your hub.docker.com. So Docker is having its own repository. So Microsoft is also having its own Microsoft Container Registry, where they have given you a lot of container images. So I will also show you there are other templates and images available in the GitHub. So here you can go and customize the graphics card, or the capacity that you need. So you can configure the sizing based on your container requirement. It generally needs very less CPU and memory compared to your virtual machine. So you can just give one CPU and 1.5 GB. That is more than sufficient for now. Let me go and create it. So within networking, as I told you, you have three options. So public, private, and none. So if you want to have public, it will be accessed using internet. So you can give a DNS name label. I will just call it as the same name, stand test container. Okay, and you can also allow it to be accessed from outside, whether you want to use it within your Azure tenant. You can just select DNS name at your Azure tenant, and if you want to have secure port, you can also go and update the port here. So it supports both TCP and UDP. Okay, you can go and update the port number if in case you are having a secure one. Okay, so restart policy is a little interesting. So restart policy, if your container fails, what it should do, whether it has to restart if there is a container failure, or whether it should kind of continue to run, or whether it should deploy it if there is a failure on your container. So the container state, if it fails, automatically you can go and restart it. So you have a restart option or a restart policy. So if the container stops, you can restart it, or if the container fails, you can restart it, or if the container exits, you can restart it. So there are three classes where you can go and configure the container to try and restart automatically to fix it. So this is for automatic fix. Okay, you can use the Microsoft native key for securing your container, or you can also use customer managed key for doing it. So what it says, we did not select subscription is disabled. Okay, so this is another account. 1 minute. So we created a lot of high-end resources this week for database sessions, and it ate all the capacity. So I'll have to use my own thing. Let me quickly create it again. Just give me a second. So let me just select this, stan Azure and test container 1. So no, nothing. This is fine. This is fine. This is fine. Stan test container 1. Click on next. Review and create. So currently this one is on Microsoft MCR, and we have this hello world, but then we will create something on Linux container. We will just try to create this and I'll show you that. So instead of this basic one, we'll also create one more. My account is pretty slow. Let me just create it and then I'll create one more. Let the deployment get started. It's initializing. Okay, it is submitting the deployment. Yeah, it is deployment in progress. Let me go one step back and then try to create one more in a different flavor on a Linux container. Stan Linux test Linux container 1. So here, instead of, so here I will just go for Alpine Linux. As I told you, it is the smallest Linux operating system we have. I will just go for this. So done. Standard is fine. Stan Linux container 1. You have one more. Okay, restart policy. That is fine. Let me create it. So even for creation also, if there is an outage, if you have the container image, to fix the issue, you just need 1 minute or half a minute to fix the issue. So these days, the outages are very, very less because of these reason. So your entire container application can be a very small package, and it takes few minutes to fix the issue or roll back, or if you want to restore the point in time snapshot, it is pretty straightforward, very quick. Okay, let it get created. So go through the Docker series, which is available openly in the public internet from my channel. So that gives you a lot of in-depth idea how to create the Docker image, how to publish it, and so on. We will also see how to create a Azure container image and then publish it to Azure Container Registry and spin that up. So if you look at here, this container has come up online and it has given a specific FQDN for us. So it has got one container running here. Let me try to enter this link and then see what happens. So we have this container available. It is taking some time. So yeah, it has come up with the Nginx web page. See, behind the scene, it is using a flavor of Linux, Alpine Linux operating system, and it does also have a Nginx web server. So assume that if you need a similar web server on your Windows, you need to have a heavy Windows operating system. On top of that, you need to install IIS, and then you need to do a lot of configuration. So it at least needs 1 hour to get all those things done. And then if you want to make changes, it is very tough. So here, if you want to have an Nginx web server running on Alpine Linux, it takes very few seconds to get it deployed. So you have the web application running, and let me go and just do some refresh to get some load here. Okay, so you'll also get to see some utilization. You can also access it using IP address if in case you want to. So it's available with Microsoft fully qualified domain name, or you can also access it using IP address. If you want to connect to the container and log in, you can just go to the containers here. So you also have option to connect using PowerShell and command line. And if I want to just log in inside that container, I can log in here only. Even you can log in using your local machine. So if I want to log in, I can just say connect, and it will log into my Alpine Linux here. So I can just go and check Just a second. Yeah, so you can see that. You can also see that it is showing my sandbox account. It is showing the entire Linux hierarchy. So you can see that it has got its own independent private IP address, and it has got NATing to public IP address. So all these things you can do, whatever Linux related work you do, you can do it within your container. You have option to connect to it individually, and whoever is accessing, if you want to get the logs, you can easily get that here. So you can see that someone is accessing from this IP address, and you can see it is responding on port 80, and the user whoever is accessing it using, see it is also showing whether they have used the IP address for accessing or whether they have used the FQDN for accessing it, and it shows what kind of client IP address, the browser that they have used. All those logs are also available from this logs here, and you can also go and make some minor changes on the properties. It's a very small thing. If you want to increase or change the configuration, you can go and change it. You will also get all the events, whatever changes we are making. You can also go and get that here. So if you go and check the containers here, the event section, it will show you what has been changed or which image was pulled, what was how it started, what time it was started, and all those things are available here. So you also have option to go and do some custom changes using PowerShell or the Bash shell. If you want to do some automated task, you can also do that. It is very straightforward, very small. I mean, very few options to manage, so your applications can continue to run in a much easier way. So I know, like some of you may, I think most of you said Docker is new to you, so that's the reason it might be a little tough to understand. But if you go through that entire series of Docker, you need at least 4 to 5 hours. So if you go through that, you can master Docker in very less time. Just go through that when you get some time. Okay, if I want to teach that here, I need at least 3-4 weeks. So instead, you can just go through that and try to run the Azure container instance. So maybe tomorrow we will connect and create a Azure container image, upload it to our registry, and then we can try and run the Azure container instance in the cloud platform. So for now, I think we had a lot of discussions around what is containerization, and we compared it with virtualization. We also discussed about what exactly Docker is all about, and we have a Docker flavor available in Azure platform, which is called ACI, which is a flavor of Docker in Azure platform. So any questions so far based on the discussion today?
Yeah, well explained, Stan. Today
No
only
problem.
understand what is DevOps.
Oh, DevOps. Okay, DevOps. I mean, we are planning to have a session starting January. We will have a complete Azure DevOps, which is focused on Azure. So you will get to understand Azure DevOps pipeline and different tools. So don't worry about DevOps, but at least this one, Azure containers.
Why the people call DevOps? Today only know. Oh, they're meshed together, two teams.
Yeah, they have merged their teams together, and they have the same process and procedures followed. The framework is the same for both infrastructure creation as well as the application creation. Yes.
So the Kubernetes also doing the same functionality of the Dockers are different.
Yeah, as I explained on a very high level, see, Kubernetes is a equivalent tool like your vCenter. See, vCenter, it manages all your
So that's the product
vSphere.
also as a Docker or different
No.
I mean, the product.
Kubernetes, it earlier it supported Docker, but it can support all the different container platform like your container D, your LXC. So yeah, whatever different containerized platform you have, all those platforms can be managed centrally using your Kubernetes platform.
Oh, I see.
Yeah. It's not,
Thanks, Stan. Well,
it's not just meant for Docker. Docker is also supported earlier, but nowadays Docker has been acquired by a different company. So they have their own Kubernetes flavor. So they have slightly parted their ways. So Kubernetes is completely open source, and it is also available as a option in Azure platform called Azure Kubernetes Service. It's a
I
yeah. We'll get to understand that. Maybe we have a detailed session in our channel, which is already open to everyone. So you can just go and search AKS Skill Up is 10. Anyone can go and learn it. So it's in public only. Yeah, so here it is. So you can go and learn Azure Kubernetes service from scratch. So it is very much explained in a very detailed way. Even if you want to learn Kubernetes also, you have a lot of playlist here. You can go and learn the Kubernetes from scratch. That is the almost 50-hour session. Okay, don't get too much into that. For now, you don't have to really learn any new technology and stuff to run container instance. So the developers will create the package, and you can run it on Azure as a Azure container instance, and you have options to manage it, restart it, to find out the logs and everything. It is very much simplified into very few tabs here, and you can go and do all the activities that you want. So we'll also have a short session tomorrow on how to create the container image and how to manage these things. I will show a quick demo and you will get to understand it better. So any last minute questions today?
How is the security is done? Suppose you want to establish a security like any role-based security or any kind of a security, how
Yeah,
you
yeah.
can do it in
Permissions
this?
can be given. You can integrate with all the Azure products. Like if you're running web application, you can definitely have integration to your WAF or any Azure firewall can be brought in. So see, again, it like it's like your earlier days. Okay, so in one server we used to run one operating system and we used to run multiple application. So only thing that has been added here in order to provide the segregation and isolation from one another is the Docker engine. Okay, so Docker engine is the only tool that has been added in between the older days. So these two are looking very much similar, right? Only thing is we have added additional layer. Okay, that is not going to uh, reduce your security, or it is not going to impact your security. There is no security loophole. Whatever old school security itself is enough these days. But security has evolved a lot. There are a lot of vulnerability tools. There are a lot of ways to restrict your traffic, and there are a lot of ways to expose your web application by having an in-between DMZ layer. So things have evolved. Okay, so don't worry about security. A lot of customers, even banking applications, are running on container platform.
Okay, sir.
No worries. I mean, yeah, I know it's a short answer, but you can get to understand Kubernetes and Docker in very details by going through the sessions.